Kirkman. Hello and welcome to an SBAC quick lesson on geometry. So we are recording these lessons because these are things that we typically don't get to until after SBAC has occurred. We get to them at the end of the year, but you will still be asked questions on SBAC. So we're going to do a quick little lesson to kind of give you a heads up on some information so that you are not totally lost on SBAC and maybe you can answer some of these correctly. There might be things that you already know too. All right, so this one's specifically on geometry. So you're going to take your little note taker and I'm going to highlight and we're going to write down some important things. So what we need to know first about geometry is area formulas. So we're only going to find area formulas for quadrilaterals, which are four-sided figures. And we're going to do them for triangles. So the first four-sided figure is a rectangle. Okay, and you need to know that the area of a rectangle is base times height or length times width. Okay, where the base is the same thing as the length and the height is the same thing as the width. Both are true. It just kind of depends on if you're looking at this 2D shape or a 3D shape or just kind of what level you're looking at it there. But in elementary, they talk about length times width. So it's the same thing, base times height. Now, if you're sitting there going, what's a rectangle, Miss Kirkwood? Well, a rectangle is a four-sided figure that contains four right angles, okay, two sets of parallel sides. So these two sides, the heights are parallel and they're the same size, congruent, and the bases, the top and the bottom, are also congruent and parallel. That makes a rectangle. A parallelogram, okay, its area is also base times height. But because a parallelogram is basically just a rectangle that you pushed over, and it's just kind of leaning a little bit. It no longer has four right angles, but it still has four sides with two sets of parallel sides. That's where it comes from, parallelogram, because it's got parallel sides. Now, the only difference between a parallelogram and a rectangle is that its base is the same, but its height is how tall it is from one base, from the bottom to the top. Notice that I am not taking the length of the side because it is at an angle. When you find the height of any shape, it must be taken at a right angle to the base. Okay, that is my height. Also, if you notice, if I were to take this shape right here and I were to move it over, I would get a rectangle. And so that is why if the formula for area of a parallelogram and rectangle are the same, because they are the same shape. It's just one's pushed over, one's leaning over a little bit. Okay, so I'm going to erase this a bit. Okay, there. All right, the next four-sided shape you need to know is a trapezoid. Now, a trapezoid is a four-sided figure that has one set of parallel sides, the bases. Okay, the other sides of the shape are not parallel, and therefore its height is usually also like the parallelogram from a 90-degree angle from the bottom base. Okay, you can also see right trapezoids. They look like this, and they do have a right angle in there. This is still base 1, this is your height, and this is base 2. So these are two different trapezoids you might see. Now, the formula for a trapezoid looks pretty funny, but it's pretty basic. Think of it like it's actually very similar to the formula for area of a triangle, because if I extend my trapezoid up, it kind of is part of a triangle. You see that? And so it's the same kind of formula, except that we have to add the two bases together. So it's 1/2 times the two bases added together times the height. So it's just like base times height, except you've got two bases and you're going to find half of that in the end. Okay? Now, if you're sitting there going, Miss Kirkwood, I don't understand this because I don't know the formula for a triangle, that's what we're doing next. And if anytime you need to go back and pause and write down things, please do. All right, triangles have one formula, and that formula is base times height divided by 2, or some people write it as 1/2 base times height. And that is because all triangles are really just half of a rectangle or a quadrilateral. If I cut this triangle in half diagonally, or this rectangle, I get 2 equal triangles. So that's how you can remember a triangle's formula is just half of the base times the height. Okay, so you've got equilateral or acute triangles like this, where its height is going to be from its tippy top point down to at a 90-degree angle. You have right triangles like this, where its height will be included as one of the sides. And then you have obtuse triangles like this, where its height is actually overextending from its base. This is still 90 degrees from the base, but we always take the height from the base to its tallest point. Okay, remember, a triangle is just a decomposed form of a rectangle that is cut in half diagonally. All of these triangles are technically just rectangles or parallelograms that have been cut in half. Okay, even this guy, if I put another one there, it makes another parallelogram. Okay, there we go. Okay, next, after area, we get volume. Now, volume is basically the area of a 3D shape. It's the amount of space that a 3D shape takes up. Okay, and it's written right here, the amount of space a 3D object occupies. To find the area of, or the volume of a shape, we're going to do rectangular prisms. You're just going to find the base times the height times the width. Or, in other words, you're finding the area of this base, the area of the bottom, which we know is length times width, or base times height. And then we're multiplying that there by here. This would be your little b for base. So we've got base times width times height. You're just going to multiply those three together. Okay? And we'll do some examples here. The last thing you need to know is what surface area is. So think of area of a shape, and then think of a 3D shape, and ask yourself, what is the area of the outside of that 3D shape? Well, that's surface area. So it's the total covering on the faces of a 3D object. For example, when you wrap a present, you're covering its surface area. When you make this cardboard net, that like these things that are down here, that's surface area. If you're painting the sides of a 3D figure, you're painting its surface area. And all you have to do to find surface area is find the area of the various faces and add them together. So you're just going to find the area of each piece and add them together. These are the shapes that you're expected to know. This is a triangular prism. Okay, and that's where you're going to find the base is this these two little triangle pieces. But all you're going to do is you're going to find the area of this, the area of this, the area of this, the area of this, and the area of this, and you're going to add them all together. Okay, same thing here. Find the area, the area, the area, the area, the area, the area, add them all together. This one is a net of a rectangular prism. Over here we have the net of a square pyramid. And over here we have a net of a triangular pyramid. And the same thing, you're going to find area, 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 add them together. Area, 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 add them together. All right, let's do some examples. So that was our notes. If you need to go back or write down, great. But let's do some examples so you know what we're doing. So because you're in 6th grade, they are going to use fractions and decimals when finding the area of these shapes because you know how to multiply and divide fractions and decimals. So because this is a rectangle, we should know that the formula is length times width or base times height. So I'm just going to do 1.5 times 4.5. Okay, we're going to turn them improper and make that 3/2 times 9/2. And then we're going to multiply 9 times 3 is 27, 2 times 2 is 4, and then we can simplify again. 4 goes into 27 6 times with 3 left over. And then we always do our area units with a little square. This is inches squared, or inches to the power of 2. But that's it. That's all we did. Length times width, and we found our area. Now in this problem, it's asking it a little differently, so we're going to have to draw a picture. It says an international soccer match takes place in a field. So let's draw a soccer field, which is a rectangle. The area of that field is 9,600 yards squared, and the length of the field is 120 yards. We need to find its width. So if we set up our formula, area equals base times height, or length times width, I know my area, and I know my base, but I don't know the height or the width. We'll use width. I'll change that. So what I'm going to do is divide both sides by 120, because remember, we need to make that mirror, and we need to isolate the W all by itself. So we're going to get rid of the 120, and that will get me my answer here. And if I divide 9,600 by 120, I get 80 yards. So my width is 80 yards. All right, here is a parallelogram that we have to find the area of. Remember, the area of a parallelogram is still just base times height. Okay, this is my base, and this is my height. The problem is each one of these boxes is worth 3. So my base is not 5, it's 3 times 5, which is 15. And my height is not 3, 3, it's 3 times 3, which is 9. And if I do 9 times 15, I'm going to get 134 centimeters squared. Easy peasy. I'm going to skip down to another question here, number 9. Here is the trapezoid. Remember, the formula for a trapezoid is very similar to the formula for a triangle. 1/2 base times height, except we have 2 bases, base 1 plus base 2. So that's what we're going to do. We're going to do 1/2 times base 1, which is 14, plus base 2, which is 8, times the height. Now, which of these numbers is our height? Remember, the height comes from a 90-degree angle, so 4 is our height. And that's what we're going to do. So we're going to do 1/2 times 8, 9, 10, 11, 12, 22 times 4. Now, you can do half of 22 and then times 4, or you could do half of 4 and then times 22. Both would be proper ways to get your answer. And in the end, we get 44 inches squared. All right, let's do a volume question. So here we have a volume of a cube made of smaller cubes, and every little cube has 1/4 as their side length. So all of these little pieces are 1/4 of an inch long. And we want to know the volume of the whole cube. So remember, to find volume, I need to do length times width times height. What all these 3 dimensions. But in a cube, all of those dimensions are the same. And because all of these is 1/4 plus 1/4 plus 1/4, that means that all of these are 3/4 long. 3/4 of an inch. So we're going to do 3 times 3, which is 9 times 3 is 27. 4 times 4 is 16. 16 times 4, I believe, is, 4, 5, 6, 64. Oop. So we get 27/64 as our answer. Sorry, it's so confusing. I wouldn't write properly. Inches cubed. Okay. Now down here we have a surface area question. So remember, to find the surface area of something, we're going to find the area of each of these pieces. Okay? And I know that if this is 14 centimeters, because this is a rectangle, I know this is also 14 centimeters. If this is 6 centimeters, I know this is 6 centimeters. If this is... So all I had to do was find the area of each of these boxes, which I did over here. There's 2 of every side, so I added them together and then added those totals together, and here is my final surface area. So keep practicing.